Electron affinity is the counterpart or the opposite of ionization energy. So we wrote an ionization energy reaction for sodium, but I'm going to write one here for fluorine because fluorine plus, and here I'm going to use delta for energy input, can turn into an F plus plus an electron. And for a couple reasons, that F plus looks wrong. That's a grade that hopefully we never get and really doesn't exist. Also, we never think of fluorine as being a positive ion. It is very unlikely that it forms a positive ion, but it is important to remember that every element on the periodic table, even our very stable noble gases, have ionization energies. They would just have larger values for that input of energy. Electron affinity, so here we go, EA is the opposite. It is fluorine plus an electron yields the fluoride ion. The energy associated with this is trickier to predict accurately. So that's why we're going to look just at a kind of a general trend here instead of specific values, because depending what element I'm looking at, it might be an endothermic process, meaning that I have to put in energy to force it to take an electron, or it might be an exothermic process, meaning that it becomes more stable after the electron has been gained. And with levels, sublevels, Zeph, electron repulsions, it's not always as predictable as we expect in terms of exact values, but we can understand trends based upon what we do know about Zeph and shielding. In general, left to right across a row, the attraction or the affinity for another electron increases. The metals tend to have a very low affinity. They will not attract more electrons. The halogens, and with this, the noble gases do not play or do not play nice. The halogens would have the greatest affinity or the greatest attraction because of the most Zeph, making it most likely to gain. As I go down these columns, I add more distance with the same amount of Zeph, with electrons farther from the nucleus or my empty spot farther from the nucleus, they're less likely to add or to gain. So with all of this, there are, if you looked up these values, some maybe what we would define as weird exceptions. Sodium actually can gain an electron, and it gains an electron more easily than magnesium. And that's related to sublevels within atoms. Some things have a positive value compared to a negative value. Once again, endo versus exo in an expected or unexpected way. So that's why it becomes very unlikely that we would need to know exact values or trends or even explain those differences. But it is important to know that there is a general trend here, and it is associated with gaining that electron. And most importantly, if we were told a value for electron affinity, and whether that was endo or exothermic, we could connect that with the reaction that I wrote there, where we are showing maybe some energy needs to come in to add an electron for some elements, or for elements which are most favorable to gain an electron, maybe energy is released when that occurs. So this trend will probably have the least representation on the AP exam, but it is an important one in terms of understanding the process and how it's the opposite of ionization energy.